All right, now we're going to take a look at molecular formulas, and so you can reference the steps on the back of worksheet B for the practice problems you're going to do. And we've already talked about what a molecular formula is. So molecular formula specifically just refers to the formula of the compound. So again, I've got some examples here. So glucose, for example, you've seen this in biology. Its formula is C6H12O6. That's the formula for glucose to have the properties of glucose. This is acetic acid, C2H4O2, and then we've got formaldehyde, CH2O. So they all have very different properties. So like formaldehyde is used in preservatives for like some of the dissections. Glucose we know is like a sugar that the body produces, or that the body breaks down for energy that plants produce using what is the word? Photosynthesis. Then we've got acetic acid, which is the acid that makes vinegar sour, and so forth. So very different properties, different formulas, different substances. Okay, so those are the molecular formulas. We also talked about empirical formulas. So an empirical formula is the lowest whole number ratio. So if I look at this, CH2O, well, to reduce down the subscripts, there's really no anything to reduce down. So the empirical formula for that is just CH2O. For this formula, notice that there's a factor of 2 in common with each of the subscripts, and they reduce down to CH2O, right? So I divided all the subscripts by 2 to get that formula. Likewise for glucose, take a look, C6H12O6, what factor do they have in common? I've got a factor of 6 in common, so that would also reduce down to that same exact empirical formula. So we can have multiple substances. These have very different properties, they have different molecular formulas, different numbers of atoms bonded together to make them up, but they have different empirical formulas, the same empirical formula. So it comes a time when we know experimentally how we just talked about, we'd figure out the empirical formula using mass data. But what if I don't know, or if I want to try to figure out, well, what is the actual formula? Because again, sometimes the empirical formula is the same as the molecular formula, and sometimes it's not. And I can have multiple things that have the same empirical formula. Now, there are ways to figure out the molar mass or the molecular mass for the molecular formula. Those ways, well, we'll take a look at when we get to the gas laws unit as a way to do that. Also using a piece of equipment called a mass spec, you can figure out what the mass of something is. So again, we're going to be noticing that our molecular masses, so that would be the mass of these formulas, those can be determined experimentally. So in these problems where we're asked to find a molecular formula, you'll be given a mass for the molecular formula. So you won't have the formulas yet, you'll be figuring these out, but you'll be given the molecular mass. So let's take a look at working from this opposite direction. What if I were to find the molar masses, or the molecular masses of these molecular formulas? So if I add up, just like we did earlier in the year and we reviewed the beginning of this unit, I add up the masses. So this is 1 carbon. So carbon has a mass of 12, and we have 2 hydrogens, and each hydrogen has a mass of 1, and we've got 1 oxygen. Each oxygen has a mass of 16. If I add all that up, that adds up to 30. Okay, so the molar mass of this is 30.0 grams per mole. Okay, so that's our molar mass. We might also see it referred to as a molecular mass. Okay, so if I do the same thing for this, well, I've got 2 carbons, 4 hydrogens, 2 oxygens. So I would have 2 times 12, 4 times 1, and 2 times 16. So that all adds up to 60 grams per mole. And then if I do the same thing for this one, well, I've got 6 carbons, 12 hydrogens, 6 oxygens, and that all adds up to 180. Again, I went through that kind of quickly, but you can check the math if you don't believe me. So notice these are the molar mass of each of these things. Now, for the empirical formula, all of these empirical formulas are exactly the same as this molecular formula. And notice I wanted to figure out the mass of this. Well, it's actually the same thing as this, right? 12 for carbon, 2 hydrogens, 1 oxygen. That's 30 grams per mole. We have that same relationship, the same molar mass, for each of these empirical formulas. It's all the same formula, right? So 1 carbon, 2 hydrogens, 1 oxygen. Notice, though, when we look at the relationship between the molar mass for the empirical formula and the molar mass for the molecular formula, take a look at these numbers. So it's the same exact formula. Obviously, the molar masses are the same. For this one, though, we have 60 grams per mole for the molecular formula. We have 30 grams per mole for the empirical formula. We'll notice that this number is twice the size of this number. Well, didn't we, to get from this formula to this formula, just divide all the subscripts by 2? So doesn't it make sense then that this molar mass for the empirical formula is half of what it was for this? Likewise, for the glucose, its molar mass was 180 grams. For the empirical formula, it was 30 grams per mole. And notice that 180 divided by 30, well, that's a factor of 6 difference. And that makes sense, though, because we basically divided this number of each atom type by that factor of 6. So the key to finding a molecular formula, if we have an empirical formula, is we're going to be figuring out what is this factor, and instead of instead of dividing our subscripts from the molecular formula by that whole number to get the empirical formula, then we do it in reverse. So we'll have an empirical formula given to us, or if we don't have it given to us, we know the method for figuring it out from the front side of worksheet B, and then we can figure out this whole number and multiply our subscripts by that to get back to the molecular formula. So let's take a look at an example of that. Now, just to keep things simple, I will, in most cases, separate out these problems. I'm not going to have you find the empirical formula first. In these problems, like you'll notice in the back of worksheet B, you'll be given the empirical formula to work with, and then you'll be given the molecular formula mass. And again, that would be something experimentally determined. It's not something you can figure out from information that's given. So let's say that we have a unknown compound with empirical formula NH3 and molecular mass. So molecular mass is telling me that's the mass of the molecular formula of the compound. So not the empirical formula. Molecular formula mass happens to be 34.0 grams per mole. Okay, so if we look at the steps you have on worksheet B on the back, it says compare the molar masses of the empirical formula, and we have to calculate that. So here's our empirical formula. This has been given to us. So I want to figure out, well, what's the molar mass of that empirical formula? So this has 1 nitrogen, and nitrogen has a mass of 14. There are 3 hydrogens. Hydrogen has a mass of 1. So that's 14, and that's 3 times 1 is 3. Add that all up, that's 17 grams per mole. So this is the molar mass of the empirical formula. Okay, so step 1, compare the molar mass of the empirical formula, which we calculate, to the molar mass of the molecular formula, which we've been given. Okay, so there we have both of those. Step 2, we're dividing the molecular mass by the empirical formula mass. So it's always going to be the big number divided by the little number, because we're trying to come up with a whole number, that multiplier for our subscripts. So I'm going to do the big number, so that's for the molecular mass divided by the empirical formula of the molar mass. And when we divide this, there will be a whole number. It will be very, very close to a whole number. So 34 divided by 17, that's a 2. This is what you multiply your empirical formula subscripts by. So that means that if my empirical formula is NH3, so again, there's nothing written next to the N, so that's like a 1, so you have to remember that. So by 2, multiplying everything by 2, so that would mean 2 N's, and 3 times 2 would be 6. So this would be my molecular formula. And again, if you want to double check yourself, you can add up the 2 nitrogens plus 6 hydrogens. That does add up to a mass of 34. So there you go. Okay, so we should be able to, given a molecular formula, reduce it down to find an empirical formula. So that's understanding the definition of what an empirical formula is in reference to a molecular formula. We should also be able to, given experimental data, so this has to be given to us. I'll be giving you the empirical formula, which again is found technically by the same technique that we were doing on the front side of worksheet B. And then from those 2 pieces of information, you are figuring out what the multiplier is by the subscripts to get from the empirical formula back to the molecular formula. So you're going to finish out the rest of the problems on worksheet B regarding finding molecular formulas, and then we will go over them when we get into class.